Hello everyone! Today we are going to be taking notes on section 1.1, which is integers and absolute value. Now before we get started, make sure you have your notebook out ready to take notes as well as something to write with. If you need to reference this at all, it will be located on page 2 to page 7, which is section 1.1 in your textbook. And remember, at any point you can always pause or rewind the video if needed. All right, let's get started. So our essential question for today is, how do we use integers in the real world? Some of you may remember what an integer is, and if not, it's totally okay. It's been a very long summer and we all need a little bit of a refresher. So an integer is a positive or negative whole number. Hopefully that is a refresher for some of you. And let's think of some quick examples of integers. Really, it could be any positive or negative whole number, but let's just think of a few. How about negative 10, negative 8, 0, 8, and 10. Those are a few examples of positive whole numbers. Now, something I need you to remember is that fractions and decimals are not integers because they are not whole numbers. So I'm going to give you a few examples of values that are not integers. And let's just think of a few. So for example, negative 2 over 7, it's not an integer. Negative 5.4, that's not an integer. Positive 3.1, that's not one. And let's just say 7 over 8. Those are all not integers. And why? Because they are fractions and decimals, which are not included in that integer group. Just a little refresher in case you need it. All right, so now let's move on. And you see this number line here, and I just want to refresh a little bit about integers. So see these values in red right here? Those are going to be your negative integer values, as opposed to these values over here in blue, which are your positive integer values. And you see in the middle, zeros in black because it's neither positive nor negative. Now, something I wanted to remind you of is that as the values go left on the number line, the values get smaller. So although a value may look bigger, it is actually smaller. Like when you compare negative 10 and negative 1, negative 1 is actually the bigger value, even though 1 is smaller than 10. Think about it like, for example, if you're purchasing a house and there's one negative thing about one house you looked at, and then another house had 10 negative things about it. The negative 1 had less bad things, right? So you're going to want to go for that greater value. And the smaller negative numbers are actually bigger than the big ones. Hopefully that makes sense to you. Now let's talk about as values go right on the number line, the values get bigger. Like I said, sometimes it's good to apply some real life scenarios. If there's more bad things, more negative, it's actually worse, right? And if there's more good things, it's better. So sometimes it's easy to compare it to a real life example to help us remember, if that works for your brain. All right, so let's get moving and let's talk about absolute value. So absolute value is the distance between 0 and a value on the number line. And something that's very important to note is that there's no such thing as a negative distance, right? So absolute value is always going to be positive. right? So whether we're traveling 100 feet in the sky or 100 feet below sea level, we're traveling 100 feet, right? So there's no such thing as a negative distance. Our absolute value is always going to turn out as a positive. So you can see these examples right here. The absolute value of -4, and that equals 4. And the absolute value of +4, and that equals 4 as well, right? Because in both cases, we're going to have to travel 4 units from 0 to get to that. And another important note is that the absolute value symbol is that little symbol with the 2 brackets, which is right there around those 4s. It's going to look like this. Okay, that is the absolute value symbol. If you see that, that is what that looks like. And that is what that's asking us to do. Okay, are you ready to apply your knowledge? Let's go ahead and work on some examples. All right, so now we're comparing the values. And I can already see right here that our absolute value symbols are showing, and I'm going to highlight all the ones with absolute value just so we remember to actually find the absolute value of them. So absolute value of all of these values. Remember, we actually have to find the absolute value of those before we can compare. So the absolute value of -2, remember the distance from 0 to -2 is going to be 2. The distance from -7 to 0 is going to be 7. Distance from 0 to 10 or 10 to 0 is going to be 10. And the distance from -5 to 0 or vice versa is going to be 5. Those are all positives. Something important to note is on this example with 10, a lot of people just think of absolute value as the opposite. And it's really important to note that's not true. So just because this is 10, do not make the mistake of turning this into -10, because remember 10 is still going to be 10 units from 0. Therefore, our absolute value, like I mentioned above, is always going to be positive. All right, so now that we have all these values straight, let's go ahead and compare. So 2 is blank to -1. Is it greater than, less than, or equal to? Hopefully you know that a positive number is always greater than a negative, and therefore 2 is going to be greater than -1. How do you know when a greater than symbol is happening? Just remember this. The mouth, think of it like an alligator, or some people think of it as a Pac-Man. It always wants to eat the bigger value. So if you just point the mouth to the bigger value, your signs will always be correct. All right, so 2 is greater than -1. In this case, which one's bigger? Is it 6 or is it 7? You should know these are both positive values, and 7 is bigger than 6. And remember, the mouth wants to eat the greater value, and this reads 6 is less than 7. All right, let's move on to 10 compared to 9. Our mouth wants to eat the bigger value, and 10 is bigger than 9, so 10 is greater than 9. And last one, we're comparing 5 and 5, and those values are equal to each other. So 5 is equal to 5. Got it? Perfect. Now let's move on, and let's understand how integers relate to the real world. So here's a real world example for you. The freezing point is the temperature at which a liquid becomes a solid of water, and that's 0 degrees Celsius. At what substance in the table which substance in the table has the lowest freezing point? So we're given this table right here, and we want to find which one has the lowest freezing point. Now, I think a strategy that can help us out here is ordering the data from least to greatest. And remember that our negative values, the bigger the whole number value on that looks, actually the smaller the negative value is. So let's go ahead and order these. -53 is going to be first. We can cross that one off. Then -39. Then -3. Then 35. And then 55. So our question was, which substance in the table has the lowest freezing point? Now we ordered them from least to greatest, right? So we know then that our lowest is going to be the one on the very left, which is 53. So that means that is airplane fuel. So airplane fuel has the lowest freezing point. And that is equal to negative 53 degrees Celsius. Perfect. Let's go ahead and move on to question B now. So, is the freezing point of mercury or butter closer to the freezing point of 0? All right, so if you wanted to, we can create a little mock number line here. So I'm just going to draw a line, and I'm going to put 0 in the center, or closest to the center as I can. And we are talking about mercury and butter. So let's go ahead and find those values. And it looks like butter is at 35 degrees, so I'm going to put it over here on the positive side. 35, and that one is butter. And then we have mercury, which is negative 39. And that is mercury. Now, I want you to think to yourself, in this case, what are we talking about? It's asking us which one is, oops, I did not mean to do that. It is asking us which one is closer to the freezing point, 0. So it's basically asking about the distance, right? It's asking about the absolute value. So let's compare the absolute value of both of these numbers. So the absolute value of negative 39 and the absolute value of 35. Remember, it's always going to be positive. That's going to be 39. Always going to be positive again, 35. So which one would be closer? 35 units away or 39 units away? Hopefully you are saying 35 units away is closer, and therefore we can draw the conclusion that butter is closer. All right, hopefully these examples worked well for you. You can always reference this video if you need it, and go ahead and